In this lesson, we will learn how to solve equations involving absolute values. Now, the absolute value of a number, say x, is expressed using this notation, and it can be defined in more than one way. One way is to say that the absolute value of x is equal to x if x is greater than or equal to 0, and the absolute value of x is equal to negative x if x is less than 0. So the absolute value of 7 is 7, and the absolute value of negative 3 is 3, and the absolute value of 0 is 0. Another way to define the absolute value of a number is to say that it is the number's distance from 0 on the number line. So, for example, to determine the absolute value of negative 4, we notice that negative 4 is 4 units away from 0 on the number line. As such, the absolute value of negative 4 is equal to 4. Okay, now let's make some observations about equations involving absolute values. For example, if the absolute value of x is equal to 4, then we know that x must equal either 4 or negative 4. Similarly, if the absolute value of x equals 11, then x can equal either 11 or negative 11. In general, if the absolute value of x equals a, where a is greater than or equal to 0, then x must equal either a or negative a. Okay, now let's use this property to solve the following equation. If the absolute value of x equals 3x minus 4, then we can apply our rule to see that x equals 3x minus 4, or x equals negative 3x minus 4. At this point, we have two equations to solve, x equals 3x minus 4, or x equals negative 3x minus 4. We'll begin with the first equation. To solve for x, we can subtract 3x from both sides, and then divide both sides by negative 2 to get x equals 2. To solve the next equation, we'll first expand the right-hand side, then add 3x to both sides, and then divide both sides by 4 to get x equals 1. So it appears that this equation has two possible solutions. However, when we solve equations involving absolute values, it is possible to get solutions that do not satisfy the original equation. These are called extraneous roots, and we must be sure to check each solution to confirm that it satisfies the original equation. So first we'll check the solution x equals 2 by taking the original equation and replacing x with 2. When we simplify the right-hand side, we get the absolute value of 2 is equal to 2, which is true. So x equals 2 is a valid solution. Now let's check the solution x equals 1 by taking the original equation and replacing x with 1. When we simplify the right-hand side here, we get the absolute value of 1 is equal to negative 1. Since the absolute value of a number can never be negative, x equals 1 is an extraneous root, which means the original equation has only one valid solution. That is, x equals 2. Okay, let's summarize. To solve most equations involving absolute values, first apply the following rule. Then solve the resulting equations, and finally be sure to check for extraneous roots.